what we're going to be going over here is a linear programming example where we're going to be using linear programming for planning a sales budget. Okay, so what we're going to start with is some sales numbers that we had in our previous year here, 20x1, and we want to plan our sales here for 20x2. So typically what you'd start with is some previous year sales, and then based on those sales you can make some adjustments to plan your next year's sales. And we don't want to get lost in the numbers here. We want to learn about linear programming. But nonetheless, we're going to have two different products that we'll be selling here, product A and product B, and we'll be looking at 4 different quarters here for a year here, quarter 1 through quarter 4. And then based on those numbers, previous year's numbers here, we're going to have some changes in our sales quantities here and also our selling price here. But again, we don't want to get lost in this, but we want to understand how we can incorporate these into our linear program. Okay, so based on that here, our 20x2 sales plan, this is where we want to maximize our sales. So we're going to start out with some sales quantities that we have to deal with. And again, for product A here, we have a sales quantity change. It went down 20% from last year. So based on last year's results, we now have our new proposed year 20x2's years here based on that 20% reduction here. And then for product B, it went up 25%. So again, we have those adjustments here for quarter 1 through quarter 4. So these are the quantities that we're dealing with. And then we also had some selling price changes here. And the only reason I'm throwing these in here is you can see you can put those different percentages into your linear programming or come up with those numbers, and you can look at some sensitivity analysis and see where you're going with your budget here. But nonetheless, for product A, it went up 25%, so we had a price change from $48 up to $60 per unit here. And then for product B, it went down 20% from $100 down to $80 here. Okay, so we've got our preliminary numbers that we deal with. Okay, so the next thing we have to do is move over here and we have to look at how we're going to set up our linear program here. So we're going to have some sales of the product by area and period. And the period are those 4 different quarters we're looking at. And then we're going to have for product A here and product B, there's going to be 3 different sales areas here. So you'd want to identify your different sales areas. And in this case, we're just identifying them as sales area 1, 2, and 3 here for each of those products. And then we have the percentage of sales that we're allocating for each of those areas here. And again, we're just throwing in some percentages, and you can see how you can adjust your linear programming when we get into that by adjusting your different percentages. But nonetheless, we got percentages here for each of our areas here for each of our products here. And just remember the percentage sales here for each of those, for the product A here, everything should add up to 100% in this case here. And for product B, you want to look at it 100% where you're allocating between those, in this case, those 3 different areas, but you want to allocate it total, everything has to add up to 100%. Okay, so now for our linear programming. So we've got those product A, product B, and then we identified them here by sales area. We got 3 different areas here for each of those products. And then we got those 4 different quarters here that we're looking at, or periods here in the year. So we'll just look at those quarters here. And okay, so what you're going to have to do, somehow you got to index it or come up with a matrix in your linear programming or whatever. So what I've done here, this is where we're going to be identifying the different quantities that we're going to be selling of each of those products in each of those sales areas. We're going to maximize the quantity that we're selling here to maximize our sales dollars here. So just looking at how we'd set that up here, just understand what's going on, because this is what we're going to be working with for the rest of the example here. So for sales area 1 here, quarter 1, and let's just understand our indexing, what I've done here. So I just got X here, and I have a subscript 111 plus the sales area number 2 would be X 121. Sales area 3 would be 131. Okay, just so this is the key that I'm going to be working off of. And then if I move down to quarter 2 here, I've gone from 111 here in quarter 1 down to 112. So going here from sales area 1, you can see I'm indexing it down here from quarter 1, 111, 112, 113, 114. So that's the scheme that I'm using, and you can see it here. Just looking at for sales area 2, it's go 121, 122, 123, and so forth. Same thing here for sales area 3. Just understand that indexing. So somehow you're going to have to identify these different areas here by the period you're looking at. You're going to have to identify them in your programming, put them in here, either through a matrix entry, or in this case, I'm actually using those numbers here. And then the same thing here for product B here. You can see, but the thing here with product B, again, you can see here that I had to add in, index the variable here from x111. I'm going from x2111 and then x221 and so forth here. So I indexed between product A and product B. I also made an index here, but nonetheless here I'm following the same pattern here in product B. Just looking at it here for quarter 1 here, 1 2 1 1 period. Excuse me here for area 1, and area 2 is x221, area 3 x231. Okay, so you see the pattern that's going on. You have to come up with some sort of scheme here. If you put it in a matrix form or whatever into your linear program. Okay, so now we know the scheme here, so now we can start setting up our constraints. Okay, so the first thing we want to do is we're going to look at the product A constraints and product B constraints in terms of these sales quantities here. Okay, so just looking at product A constraint here, if we just move off your first matrix or first identifying matrix that I have here, just take all those variables, those indexing variables, and put them down in here. You can see x11, x121, x11, x21, or x12 here, and so forth here. Just move that right down here. And the same for product B. I'm just going to move that matrix or that sequencing I have down into my product B constraints here. And then for the quantity constraints here for product A, let's just go and look at them. That's moving over here. That's coming off my sales plan here for product A by quantity here with those 20x2 changes, and product B by quantity here. So if we move back down here just as a reference, you see product A, I moved from my initial sales adjustments that I looked at for the year, I moved them down here. And the same thing for B, just move those down in here. But the key is here, when you're setting up this linear programming, equals. Everything is equal. Take this matrix here, those numbers, and they're all going to be equal to whatever product quantities you're looking at. Same thing here for B, that equal sign. However you put it into your linear program, it has to be an equality in order for this to work. It can't be less than or greater to or greater than or less to or less than equal to, whatever. You know, it has to be an equality. It can't be an inequality. Okay, so that's for our first constraints here based on our quantities for both of those products. And then let's just jump into our objective function here. Okay, so for our linear programming, we're going to have this objective function, and that's to maximize sales here. So what you're going to do here, maybe, first off, maybe just look at the sales price here. You're going to take, for just moving up over here, you see for product A, it has a $60 selling price, and product B has an $80 selling price. So what you're going to do in your objective function, you're going to put those sales prices in here, but they're going to be times all the, you see all this, how I got this x111 plus x121, x131, all those index amounts. So that is for my product A here. Okay, so let's just go back and look at that. So I'm taking, again, what I'm doing is I'm just taking this matrix that I have here, and I'm just taking all those we're just adding everything together here. Adding everything, just I got these plus signs in here. And same for product B here. I got everything added together here. Actually, in this matrix, you really don't need those pluses in here, but I put them in just because it was easy to do here. But nonetheless, just taking those, and we move back to our objective function. So you can see what's going on here for product A here. Got all of them added together. That has to be you're taking 60 times that whole quantity here. Actually, what you have to do is you have to distribute those here in your linear program. But however you set it up in your linear program, it's taking 60 times x111 here, plus 60 times x12 here, and so forth. But these here represent your different quantities that you're looking at based on those different areas here by the period here. Okay, so that was for product A here, and then $80 times, again, that entire quantity here for product B that you're looking, and that was x211 plus x, and these things all have to be added together, and of course you'd have to distribute your $80 along here, along each one of those. 80 has to be times each one of those, or I'm just showing it as a quantity here. But nonetheless, you're taking all those figures that you have here off for your quarters and by sales areas here. They're identified by sales area. They're all putting in here, and you're adding them all together here, but you're distributing your price across all of those numbers here. So yeah, work with your sales price here, and then the linear program, we're going to maximize that here. So, but we'll get into, we got several constraints further to look at here that are really the key here when you're talking about planning a sales budget, and we'll go on and understand those. But again, remember these numbers here. Those determine the sales quantities and dollars here by period in area that you'd be looking at. Okay, so we'll continue on with our constraint. Now we'll set up our proportional constraints by product and area. Now this may be new to you and unfamiliar, but it's simple if you just follow along. Okay, so what we're going to do is we're going to start out with our sales by product and area here. So remember we worked off that product A, product B, and then we have those 3 different sales areas for each of the product. And this is where those percent of sales that we're estimating for each of those areas here comes into play. So let's just start here. And remember, we've got these 4 different quarters we're working with. So let's just start with our first index here, where we're looking at sales area 1, 10% here for quarter 1 here, X111. See how that fits in. So moving down to our proportional constraints, this is what we're going to do. For product A, we're going to set up here as X111 here is going to be equal to 10% or 0.10 here, or 10%. That comes off our percentage of sales here that matches it up here. And that point or 10% here takes times the whole quantity here. Actually, that row here, it's that quantity of X11 plus X12 plus X13 here. So you just take 0.10 or 10% times that entire quantity here, that entire row, and you set that equal to your first index here, or X11 is equal. It's key. You have to put it equal to as an equality in your linear programming. So we'll just follow through here for, let's look at our next area 2, 25, or excuse me, let's just look at the next one here, 10% for quarter 2 here, area 1. So it'd be X112. So just going down here, you just put X112 is equal to, again, that was that 10% that we're looking at, times the entire row here of X112, X122, and X132 here. Just take it times that entire row here, 10% here. So you see the pattern that we're working off of. So then for our next, looking at our index here for what, we'll start here for 25% here for sales area 2 here, that quarter 1 here, X121 here. So let's see how that fits in here. So we go down here and we put that at X121 here is equal to 0.25 or 25% times that entire row or that entire quantity, and everything is added together here. Okay, so that's how that's done. And then the X122 here, all you're doing is, you'll see the pattern here. So you take that, you bring that down here, X122 is equal to, again, 25% times that entire row here. Okay, so you see the pattern that's going on here, and we only did it for 4 here, but you'd have to do it for each of the areas in each periods. So you're going to have 4 by 3, or you're going to have 12 different entries. Okay, so let's maybe just move on here so we get a little better understanding here. We'll move to product B here. Okay, so just working off product B, again, we have those 3 different sales areas here, and then we got that different percentage for each of those areas. So let's just look at X211 here. Okay, so what you do here is go down into your proportional constraints. X211 is going to equal to 0.55 or 55% here times that entire row here. You have to distribute it amongst that entire row here. Wherever the item that you're working out of here, you just take the proportional of that entire row here. So that entire row here was X211 plus X221 and so forth here. And then for X212, again, we're sitting under the 55% here. You just take that index here times that entire row again here. So look at that here. So X212 equals 55.55 or 55% times the quantity. Just add them all together here for the entire row. You can't add them, but you have to put it into your linear program as such here, and you'd have to distribute it out. So then just looking at the next one, X221, where does that fall? That falls under 25% here for sales area 2, and that's for quarter 1 here. So same pattern here. Move down here, X221, 20% or 0.20 times that entire row here that we have for that X211 is sitting in here. And then finally, just looking up at X222 here, that's just taking that. Again, you're setting it equal to, again, it was under that 20% here for sales area 2 times that entire quantity, that entire row that it's sitting in here. All right, so you see the pattern. Again, you'd have to do for each of the areas here in periods. So again, you'd have 12 different entries. So between the product A and product B, you're going to have 24 different constraints here as we index them. Now you could solve knowing we set up all our constraints in our objective function. Now you could solve the linear programming for the sales quantities and then to maximize your sales dollars. But what we're going through is just, if you want to stick with us, we'll go through an abbreviated example to see how we would do this here. Okay, so we'll continue on. Now we'll go through an abbreviated example of what we've just done here to get a better understanding. So we're just looking at an example here where I got the two products, product A, product B, and we're going to just have two different sales areas for each of those products, and then the percentage of sales I'm showing here. And again, we'll be just looking at 2 periods here. So again, I've set up the indexing here for those variables that we look at, x111 plus x121 and so forth here for product A here and product B for each of those sales areas. So the next thing we have to do is we have to set up our constraints here based on the quantity that's available. So just going back to our indexing here off our sales by product and area here, let's looking at period 1 here. The row 1 here for product A here is x111 plus x121. Just bring those, and same for the second period 2 here. Just bring those index values down into your constraint equation here, and then you're going to set it equal to whatever the quantities that you have here. So let's just go look at it. For product A here, for period 1, we have 2,000, a quantity of 2,000. Period 2, 4,720. So those go down into your constraints here. And again, it has to be equal to here. Equal to has to go into your linear programming, however you set that up. Okay, so that's for product A. Product B, the quantity constraints, again, just go up off your chart here. And this is the case where we're working at x211 plus x221 here. And then that's for period 1. And at period 2, we had x212 plus x222 here. Just take your your constraints right off there, put them right down into the constraint equation here. Just move those things right down and then just set them equal to product B. Well, we had a 4,000 here for product B for that period 1 here, and for period 2 we had 2,000 here. Okay, so that's how you'd set that up here. And then for our proportionate constraints here by product and area, remember we got these product A, product B here. So just working off, let's look at it here. So let's look at this first one here, x111 here for sales area 1 at 40%, and then we'll look at the other percentages too. So just looking at x11 here, moving back to our proportionate constraint, x11 is equal to 40% here. That's the column it's sitting in here, times its entire row here. That for period 1, that entire row here for product A here, x111 plus x121. Okay, and then for x112 here, that's sitting here at 40%, sales area 1 for period 2 here. Okay, so its proportionate constraint, just set x112 is equal to, again, 40% here times that entire row. And remember, these are plus quantities in here. They're kept separate here in your linear program because it has to figure out those quantities for each of those here. But nonetheless, you take 40% times that entire quantity here. And then for x121, let's see, that's under sales area 2, 60% here, period 1. So just moving that over, x121 is equal to, remember, everything has to be set equal to when you're doing your linear programming, times 0.60 or 60% in this case here, times its entire row that you're looking at here. Well, x111 plus x121 here. You can go look at that. And then finally here for x122 here, that's in sales area 2 here for period 2 at 60%. Just x112 is equal to, again, 0.60 or 60% here times its row here. And remember, these are additive here, or they have to be kept separate in your linear programming, but you'd be distributing these percentages or these fractions here against them. And then just remember here, I didn't mention it, but when you're talking about the sales percentages, make sure that they add up to 100%. I'm showing here 40%, 60% is 100%, product B 70%, 30% is 100%. And then the same thing here for product B. So if we looked at x211 here, period 1, sales area 1, going back to product B here, x211 here is equal to, again, 70% times its row here, X211, that X211 is sitting in, plus X221 here. And then for X212 here, let's go back, that's sitting here in sales area 1, 70% period 2, that represents period 2. That goes up here, X2112 here, equals 70% X22, whatever, that row that it's sitting in here. And then for finally here, X21221, that goes over here, is equal to, and that was sitting at 30% here in sales area 2 here for period 1 here. That represents that. So X221, 30% times the row that it's sitting in here. And then X222, the same thing. We could go back and look at that. That's sitting at 60%, 30% here in sales area 2, period 2 here. That represents that. So there it goes in. X222 equals 30% times. These are all times here. Remember, they have to be sitting in at equals here, times the row that it's sitting in here. Okay, so this is exactly how you'd be handling that. And then just setting up your program here, I'm just using MapleSoft here. You have your objective function. Remember, you're distributing those prices across all your different variables here. That's $60 for product A and $80 here for product B. Okay, so you could go back and look at those. And then those constraints we have sitting here, those are just all of these sitting over here in this area. Those constraints, those are the quantity constraints. Remember, they have to be set equal to in your program. But then when we get down to our proportionate constraints, just to understand how they work here, again, we just take those right off our proportionate constraints that we figured out and then distribute it your percentage here. But what I want to show here is I'm setting that equal to 0 here. So if we've gone back here, maybe we ought to go back and look at this X111 here. If we gone back over here, you can see X11 equals 40% times that quantity here. But what I'm doing is, in a linear program, you have to set up in some standard form, however you do it. So I set it up at 0 here. So I'm just moving the X11 over to this side and subtracting it from the equation here on this side times 40% here, and then sitting at 0. That's all I'm doing here. But I would have done that for each one of our proportionate constraints. So just going back down here, you can see here, I'm subtracting each one of those proportionate constraints, or I'm just moving them over to the other side of the equation, setting them up equal to 0. And then again, we're assuming an integer solution here, and you have to have non-negative. Make sure you set up your program that you have all your constraints, all your variables are non-negative, and I'm using the maximization here. Okay, so let's see if everything has worked. Let's move over here. And this would be the results based on our abbreviated example here. So we have maximum sales dollars. I have, what, 995,200 here. And then I'm not going to go through them all, but for each one of those variables, X111, we had 800 equal to quantity of 800 here. So we're looking at the quantity by sales area for each period. In this, we have maximized our sales dollars, and it's telling us exactly what quantity we should be selling or setting up our budget for in each of those areas. So X112, that represented 1,888 quantity, X121, 1,200, and so forth here. So we got all of our, everything solved here in our matrix that we had here, because we're looking at 2 different sales areas, 2 products, in 2 different periods. So whatever that is, I guess we come up with 8 different variables here, or sales areas by period here, and we've got the solution here. Okay, so that's what you do, and really this works out pretty good, because you can just puts in different percentages and so forth, and change your prices and stuff like that, and the computer will give you a solution that you should be really shooting for here. And then one last thing here, I've just shown some 3D graphs here. Really, because you got all these variables, it would be difficult to graph them out. But you could do that here. You're going to have some sales dollars here, and then you can do it by really 2 different variables that you have here. There's 2 different product, or by a sales area here, and by period only 2 at a time here, and then you're going to come up with some. You can look at it in 3D graphs here. In this case, I used MapleSoft. Okay, so that'll pretty much summarize our example here, and it's a good little example to go over for using linear programming here for sales budget, maximizing sales, and allocating your sales by area and by sales area as a percentage and by period. Okay, so that'll summarize our example.